Hello, students of grade 4. Today, we are going to start with a new topic that is States of Matter, Unit 3. To begin, we first have to know what is matter. Everything that takes up space and has mass is known as matter. All matter is made up of atoms, which are in turn made up of protons, neutrons, and electrons. Atoms come together to form molecules, which are the building blocks for all types of matter. The three states of matter are the three distinct physical forms that matter can take in most environments, that is, solid, liquid, and gas. Solid. In a solid, particles are packed tightly together so they don't move much. The electrons of each atom are constantly in motion, so the atoms have a small vibration, but they are fixed in their position. Because of this, particles in a solid have a very low kinetic energy. Solids have a definite shape as well as mass and volume, and do not conform for the shape of the container in which they are placed. Solids also have a high density, meaning that the particles are tightly packed together. Liquid. In a liquid, the particles are more loosely packed than in a solid and are able to flow around each other, giving the liquid an indefinite shape. Therefore, the liquid can conform to the shape of its container. Liquids have a lower density than solids and are incredibly difficult to compress. Gas particles have a high deal of space between them and have high kinetic energy. A gas has no definite shape or volume. If unconfined, the particles of a gas will spread out indefinitely. If confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of the container, the space between the particles is reduced and the gas is compressed. Evaporation is the process by which water changes from a liquid to a gas or vapor. As the temperature increases, the rate of evaporation also increases. Evaporation is the process by which an element or compound transitions from its liquid state to its gaseous state below the temperature at which it boils. In particular, the process by which liquid water enters the atmosphere as water vapor. The rate of evaporation depends on the temperature difference between the evaporating surface and the air and the relative humidity and also the wind. Evaporation happens when a liquid turns into a gas. It can be easily visualized when rain puddles disappear on a hot day or when wet clothes dry in the sun. In this example, the liquid water is not actually vanishing, it is evaporating into a gas called water vapor. Evaporation happens on a global scale. Alongside condensation and precipitation, evaporation is one of the three main steps in the Earth water cycle. Evaporation accounts for 90% of the moisture in the Earth's atmosphere. The other 10% is due to plant transpiration. Substances can exist in three main states, that is, solid, liquid, and gas. Evaporation is just one way a substance, like water, can change between these states. Melting and freezing are the two other ways. When liquid water reaches a low enough temperature, it freezes and becomes a solid ice. When solid water is exposed to enough heat, it will melt and return to a liquid. As that liquid water is further heated, it evaporates and becomes a gas, that is, water vapor. These changes between states, melting, freezing, and evaporating, happen because as the temperature either increases or decreases, the molecules in a substance begin to speed up or slow down. In a solid, the molecules are tightly packed and only vibrate against each other. In a liquid, the molecules move freely but stay close together. In a gas, they move around wildly and have a great ideal space between them. In the water cycle, evaporation occurs when sunlight warms the surface of the water. The heat from the sun makes the water molecules move faster and faster until they move so fast that they escape as a gas. Once evaporated, a molecule of water vapor spends about 10 days in the air. There are many situations when this process of evaporation occurs in real life. Have you ever noticed them? If not, then here you will get to know about the different everyday examples of evaporation and how it is useful to us. Drying clothes under the sun. One of the most common real life examples of evaporation is drying clothes under the sun. When the wet clothes are put under the sun, they get heated up, resulting in the evaporation of water particles present in the wet clothes, making the clothes dry. Melting of ice cubes. When the ice cubes are taken out of the refrigerator for having drinks, we all must have noticed that after some time the ice cube melts and then take the form of a liquid. It changes its shape from solid to liquid. All this happens because of the increased temperature outside the refrigerator that evaporates the water, resulting in the change of shape of the ice cubes. Isn't it a magic as to how a hot cup of tea or any hot liquid cools down after some time? It's all possible because of evaporation. Heat loss happens as the water evaporates, resulting in cooling down of the tea and other such beverages. When you run around, your body gets warm. You may start to sweat. Sweat is your body's way of keeping cool. As the fastest, hottest water particles in the sweat escape by evaporation, they take heat energy from our skin. Water needs energy to evaporate and change from a liquid to a gas. If this energy comes from the surface of your skin gets cooled. Solution is a specific type of mixture where one substance is dissolved into another. A solution is the same or uniform throughout, which makes it a homogeneous mixture. Common examples of solution are the sugar in water and salt in water solutions or soda water, etc. In a solution, all the components appear as a single phase. A solute is the substance that is being dissolved by another substance. In the example above, the salt is the solute. The solvent is the substance that dissolves the other substance. In the example above, the water is the solvent. You cannot see the solute in a solution after it has dissolved. The particles of the solute move in between the solvent particles when they dissolve. The process of extracting salt from seawater is an ancient technology and involves evaporation ponds. Shallow, waterproof ponds are dug out and connected to the sea by means of a short canal. A broad area and shallow depth allow a given volume of water to absorb more sunlight. The pond is flooded and then the canal is closed. The sun evaporates the water. As the water vaporizes, the salt remains behind, creating more saline water. Eventually, enough of the water evaporates to leave behind a layer of sea salt crystal that can be harvested. This is all for this subtopic. We will continue in the next class. Till then, take care, stay safe.